Hello and welcome to in this session where we will be talking about kinematic versus physics movement approach, moving game objects horizontally and vertically, and moving the camera along with the game object. The session will start with the kinematic versus physics approach movement in Unity. There are two ways to move a character in Unity. One is called kinematic and the second one is called physics approach. In kinematic approach, the developer has to do the programming to move an object. It means the developer has to write the code to translate, to scale, and to rotate a game object. So the entire functionality, the entire movement of character will depend upon the script. Whereas in the physics movement approach, the developer has not to do anything except attaching a component with the game object. Now, this component will help to move or will help to apply some certain forces to the game object, such as the gravitational force, the collision detection, or the collider force. These type of forces will be automatically attached to a game object, and based on these forces the game object will be moving. So first we will understand the kinematic approach, and we will use this kinematic approach in today's session, and in a later session we will discuss about physics approach as well. So the next agenda for today's session is moving game objects horizontally and vertically. Let's work on this task, and in this session we will be using the kinematic approach in order to move a game object. Let's head back to Unity. So in this session we will be moving this sphere game object, and let me just get rid of all the irrelevant scripts and game objects from my game. So the cube game object is not required here, so I'm going to delete this cube game object. So press delete key from the keyboard, and I don't need this cube script also. I'm going to delete this one. First click on the script, then right click and then press the delete option from the menu. Delete all the three scripts as well because we don't need it at this stage. So right click and press the delete option from the available context menu. You can select and press the delete key from the keyboard as well. All set to go. Just make sure that there is no script attached to the sphere game object. So select the game object in the hierarchy view and look at the inspector window and see if there is any script attached to it. As you can see, there is one script attached to it. So we need to get rid of this component. So click on these three dots, settings button, and click remove component. The script has been removed from the sphere game object. Let's create a new script, and we will attach this script to the sphere game object and we will program it. Right click in the empty space inside the script folder, go to create, context menu, and click on this C# script. Name this script as sphere movement. Press enter to register this name. Now double click and open this script in Visual Studio and make some changes. Well, the script is ready to accept the changes. So let me just zoom in so that you can see. In the update function, we will be calling transform.translate function in order to move this game object, which is sphere. Remember, this script has to be attached to the sphere game object, and later once we complete the script we will attach it to the sphere game object. So what we are doing right now, moving sphere horizontally. Game object horizontally. So we will be calling transform.translate function. Transform make sure the transform t is small case dot translate, and this translate t is capital. From this pop-up menu, I'm going to select this translate function. Press the tab key to complete it. Excuse me, I made a mistake. Let me just rectify this. Transform.translate. So use the tab key to complete this function. Open parenthesis. Now I want to move this game object horizontally. Horizontally means over the z-axis. So the translate function is going to accept three values. X value, the first one is the X value, the second one is the Y value, and the third one is the Z value. So there will be no change at X-axis, there will be no change at Y-axis, and there will be a change frames per second. Okay, the movement of this game object will be frames per second. So what we will do, we can attach here directly input dot get axis, input dot get axis, and we are going to accessing the horizontal axis. Horizontal, make sure the spellings are correct, and we will be multiplying with the speed of, let's suppose, 3. So it means 3 meter per second it is going to move, or based on the frame rate it is going to multiply with 3 and it is going to move the game object. And with semicolon here, save this script. Open you. Now attach this script, which is sphere movement script, to the sphere game object. You can drag and drop on the sphere. Select the sphere game object from the hierarchy view and you can check whether the script has been attached to it or not. Now you must be thinking, we use the code over here horizontal. What is the meaning of horizontal? If you wanted to see what is the meaning of horizontal, you can go to the edit button and then click on the project settings and then click on this input manager. From this dialog box, in the input manager, select this horizontal or expand this horizontal tab. Now in the horizontal tab means the navigation buttons which are mapped with it, you can use the keyboard left key and the right key, or the alternate keys are A and D keys from the keyboard. It can also accept the input from the joystick and many other different types of input providers. So in the script, horizontal means if you press A and D key from the keyboard, A will move the object left side and D will move the object right side. Similarly, if you press the up arrow key or the down arrow key, it is going to move this object accordingly. Up arrow means the displacement will be +1. Down arrow means the displacement will be -1. And if you press the A key, the displacement will be -1, and if you press the D key, the displacement will be +1. So let's run this game. Let me close this dialog box, project setting dialog box, and let's run this game and see the output. As you can see, my game object is moving over here, but it is moving very fast. How can we adjust the speed for this game object? So head back to the Visual Studio. We are multiplying it with the speed 3. You can adjust the speed to, for example, 2, and you can check the behavior. Similarly, if I wanted to move my game object on y-axis, then up and down, what code we will be doing over here? We will be changing this code accordingly. Let me add moving sphere game object horizontally and vertically. So remove this 0 and type here input dot get axis. This time we will be using vertical axis, multiply with the speed of 2. Save this script, head back to Unity. We need to stop and rerun our game. As you can see, our game object is moving up and down with the help of up arrow and down arrow key, and left and right with the help of left and right arrow key. Similarly, you can press A and D keys to move this game object horizontally, W and S keys to move up and down. Well, you might have observed the speed of this sphere is very fast, and we need to adjust this speed. This is happening because if you see the script, we are multiplying this with 2, and the movement is based on the frames per second instead of meter per second. Now this frame per second is different on different computers. Again, the frames per second may vary on a same computer after some time as well. The reason could be it depends upon how much load a scene has. If the load of the scene is increased, obviously the frames per second may go down as well. Now to avoid this issue, what we can do, first of all, we need to adjust the speed. We need to declare a variable for this speed, plus we need to multiply this with times dot delta time as discussed in our previous sessions also. So first of all, I'm going to declare a variable over here, and this variable is, you need to declare it public in order to access it in the inspector window, public, and this is going to be float, and I'm going to call it here speed. Now this speed, what we will do, instead of multiplying it with 2, we will multiply it with speed variable. So give some spaces so that your code should look clean. Now multiply this, replace this 2 with speed. Similarly, we need to add one more thing over here. Instead of frames per second, we want to move this sphere with meter per second. So what we will do, we will multiply it with time dot delta time. So with the addition of this statement only, now our sphere will move meter per second if the speed is set to 1. If we set the speed to 2, then it is going to be 2 meter per second multiplied by times dot delta time in both the cases. So we made these changes. Save your script, open Unity. Now you will observe one change in the inspector window. Select the sphere and go to the inspector window and see the script. Initial, the speed is set to 0. Change the speed to 1. So it means sphere is going to move 1 meter per second. So set the speed to 1 and let's play the script. Now if I move my sphere using the up and down keys, you can see it is moving up vertically, and down keys it is moving down, and speed is quite normal as well. If you want to increase the speed, just open the inspector window and set this speed to 2. Press enter. Now this time the speed will be 2 meter per second, and let's see the changes. As you can see, the speed is much faster than before, and it is going to move 2 meter per second, left and right, up and down. As you can see here. Now, what we want, the last part of this session is, we want to move the camera along with the sphere game object. This is going to be super easy. What you need to do, you need to just make this main camera a child for this sphere game object. How to make a parent-child relationship here? The easiest way is, you can drag this camera, main camera, and drop it on the sphere, and make sure that it should look like a child. Look, you can expand and you can collapse this window. Now you see, sphere has a child, and this child is main camera. Now if I run this game again and see the output, you will observe the way your keys are moving, or this sphere is moving. Similarly, the camera movement will also be reflected. Look at this. The camera is also moving along with the sphere movement, as you can see here. As you can observe here, the camera is also moving along with the sphere based on our keys selection. Well, that was all about in this session. I hope you have enjoyed the learning. I'll see you in the next video.